How do arrow functions work without a prototype in JavaScript? Imagine you're building a house and you want to create a blueprint for the rooms. Regular functions in JavaScript are like those blueprints. They come with a built-in plan called a prototype. Arrow functions, on the other hand, are like quick sketches. They don't have that blueprint. This difference is key to understanding how they work. Regular functions automatically get a prototype property. This means you can add shared properties or methods to their prototype, and all objects created from that function will share those features. It also means you can use the function as a constructor with the new keyword to make new objects. But arrow functions do not have this prototype property. They are not meant to be used as constructors. If you try to use an arrow function with new, you'll get an error because there is no prototype to link to the new object. Since arrow functions lack a prototype, you cannot add properties or methods to them for inheritance. They are designed for short, simple tasks like callbacks or inline functions. They are not for creating objects or sharing methods across objects. This is because arrow functions do not have their own this value. Instead, they inherit this from the surrounding scope. This makes them predictable and easy to use in many situations, especially when working with asynchronous code or event handlers. Arrow functions are perfect for writing quick functions that don't need their own this or prototype. For example, when you want to transform an array with map or filter, arrow functions make the code cleaner and easier to read. Because they inherit this from the outside, you don't have to worry about binding or losing context. This is especially helpful in asynchronous programming, where maintaining the correct this can be tricky. To sum up, regular functions have a prototype property that allows them to be used as constructors and support inheritance. Arrow functions do not have this property, so they cannot be used with new or for inheritance purposes. Instead, they focus on simplicity and lexical this binding, making them great for short, inline functions. Understanding this difference helps you choose the right function type for your code, whether you're working with objects, inheritance, or asynchronous tasks.